Commonly, over a few weeks of consistent MIP operation, the XSD baseline and, more importantly, the responses to similar TC concentrations will be reduced. This video will show the procedure for cleaning the XSD components, which will improve overall response and extend their life expectancy. The first step of this process is to run a chemical response test, here using 5 ppm of TCE. This will provide us with a baseline response of the PID and XSD detectors, which will help us to determine the consistency of the response to standard, as well as how well the cleaning has helped the XSD performance. Here, the top black line is the PID response, and the lower blue line is the XSD. Once we have this data, we can allow the detectors to cool and get on with the cleaning. Once cooled, you will want to remove the XSD signal cable and the heater cable, twist the cell toward you, and pull away from the GC. Once the XSD is removed from the GC, we can remove the 3 screws that hold the upper probe assembly section in place. This is done by using a small slot drive screwdriver. Once the probe assembly has been removed, see if you can observe any shiny flakes or sparkles on the ceramic arm of the probe assembly. These flakes are bits of platinum that have split off of the electrode and collected on the ceramic of the probe assembly and also on the inner wall of the reactor core. These flakes reduce the XSD sensitivity by providing alternative locations away from the current measured electrode for free halogen atoms to bond. So we will want to remove as many of these platinum specks as we can. The best way to do this is to take a dry cotton swab and gently rub the ceramic arm from the end toward the body of the probe assembly. Do this all the way around the ceramic, turning the cotton swab as you go, applying only mild pressure to the arm. Be sure to look closely and remove any cotton fibers that may have been left on the ceramic when finished. The next step is to remove some fibers from a new cotton swab so it will fit down the center of the reactor core. The platinum specks will adhere to the inner walls of the reactor core, so this is a necessary step to complete cleaning of the XSD detector cell. Be sure to run the cotton swab down both ends of the reactor core. Once this has been done a few times, you can inspect the probe assembly and inner portions of the reactor core to see if you've made any improvements. When we have determined that the elements are clean, reassemble the detector cell by installing the probe assembly back into the reactor core and reinstalling the 3 screws. Then replace the detector onto its base of the GC, installing the heater cable coming in from the top and the signal cable on the end of the probe assembly. Then allow the XSD to heat up and stabilize for approximately 20 minutes before rerunning our 5 ppm TC performance test. So here we're going to start the post-log test running the same concentration TCE standard. I'm doing this as a post-log test in the same run I did earlier so I can easily compare this in the DI viewer software. Now we'll compare those response runs here in the DI viewer. Here's the PID. Post-log had a higher response, probably due to injection. I think that was 20% higher. When we look at the XSD, we also see a higher response in the post-log test, which is about 45% higher. So the cleaning definitely added to the improved XSD response. If we go to multi-view, we can look at both of these logs overlapped. And again, we have the PID, see increased response there, and how much higher that XSD response is visually to that. So both the injection and the cleaning influence the response on the XSD. Hopefully, when you go through this process, you'll also see an improved XSD response.